Welcome back to Unit 6, Geometric Vectors, Lesson 3, Multiplying a Vector by a Scalar. We're going to continue on with Example 3, Linear Combination of Vectors. So the question says, in a trapezoid ABCD, BC is parallel to AD. So these two sides of a trapezoid are parallel. AB is equal to U, so that vector there is equal to U, and BC is equal to V. It says express AD, BD, CD as linear combinations of U and V. So we'll start off with the first one, vector AD. So what I'm going to do is I'm going to start, there is a tail, there's a tip, so I want to go from here to here. Now I know that BC is equal to 1/3 of AD. So because I know this, I can write this as AD is equal to 3 BC. And again, I know vector BC is actually equal to V. So AD is equal to 3 V. Next one I want to do is BD. BD, so I want to start here and here. The problem with this one is that I don't have no idea what the vector CD is, so what I'm going to do is I'm going to have to reverse it. I'm going to go BA, which I know that's negative U, plus AD. The nice thing is, I already have AD, I did AD up here, and it's equal to 3B, and I know since AB is equal to U, then I know that negative AB plus AD. Now I can replace both these vectors with U and V. So that's really going to be negative U plus 3V. So that is BD. All right, next one I said I want to do CD. So CD, so I want to do this to this. Again, I have no idea what that vector is, so I'm going to have to go around the trapezoid. So I have to do CB plus BA plus AD. Now, I know that BC is equal to V, so I can change the order of this and make it negative. So negative BC plus, same thing here, negative AB, plus, and now I know AD, again, from up here is 3V. I'll leave it as AD for now. So BC is actually equal to negative, BC is equal to V, so I can have negative V plus negative U plus 3V. Add like terms, negative V plus 3V is 2V minus U. So CD is equal to 2V plus U. Example 4. It says ABCD is a pentagon such that AB is equal to DC. So AB equal to DC. So this vector here is the same as this vector here, which is good to know. And I also know that AC, so this vector here, is 2 times this vector here. So why did I highlight that? Because these are the ones that I can use. And so I'm going to use these. And it says express each vector in terms of AB and AC. I'm just going to rearrange this one. I'm going to divide each of these by 2. So I really have 1/2 AC is equal to ED. Why would I do that? Because I want everything written in terms of AB and AC. So if I get a vector AD, I can actually write it as 1/2 AC. So before I even started anything. First one says EC. So I want to start here and here. So that's equal to start here, so I'm going to use ED. Everything is highlighted, by the way, I can use. If it's not highlighted, I can't use it because I have no vector to represent that. So ED. So ED is, ED of course, Mr. Wills, come on, plus DC. Again, I'm going to use this fact up here, came in handy. I know AC, or I know ED is equal to 1/2 AC, so I'm going to replace it with 1/2 AC plus, and I know ED, already did that one, sorry, DC, my apologies. DC is actually equal to AB, and so I am done. That's it. All right, CE. So again, I want to start here and here. So if you look, it's actually the opposite of this vector here. So I can write it out as, but you're going to see that it's going to become the negative of both of these. But I'll do it anyway. So CD plus DE, which I can rewrite as DC plus, or negative DC, my apologies, plus negative ED. Why would you do this, Mr. Wills? Because I know what ED is. ED is 1/2 AC. I know what DC is. That is just AB. So I know my answer will be negative DC, which is actually AB. And then this is minus 1/2 AB. And as predicted, that is what the other one gave me as well, because they're opposite vectors, so I could just change the sign of both. CB. So CB, I'm going to do it down here. Let's do it right here. So CB is equal to, so I want to start here and here. Again, I can only use what's highlighted here, so I'm going to have to use CA plus AB. So CA, well, that's really just negative AC. So beautiful, I've already got that one in terms of that. And the other one is AB, I've already got in terms of AB, so there's my answer, done and done. All right, AE. So AE, I want to write it. So I want to go from here to here. I can't do that because there's not highlighted. I don't know that root, but what I can do is AC plus CD plus DE. So I'll write that in. AC, that's nice. That's one of the vectors I need to write in terms of. CD plus DE. Now I've already got my AC, so that's nice. Plus CD. Now I know DC is equal to AB, so I'm going to write it as negative DC. Plus, and I know DE, I'm going to make it negative ED, because I know ED is equal to 1/2 AC. So continuing on, AC minus DC is equal to AB, so minus AB. And then this is going to be minus 1/2, because again, ED is equal to 1/2 AC, negative 1/2 AC. Do I have any like terms there? Absolutely I do. I have AC minus 1/2 AC, which will give me 1/2 AC minus a